Thank you, Ernesto, for inviting me to visit and for all of you to coming to this talk. Now, even though I've been in the economics profession now for almost 4 decades, I'm always still a little nervous at the beginning of a talk and at the beginning of a class. And so I always tell a story of some kind. In this case, there's a very natural story. When he was at Boston University, Ernesto was a star student, but he also developed a reputation for being an excellent stand-up comic. And so when the PhD students were having a skit to uh, lampoon the faculty, he was nominated to play me. And so he started off by telling a bunch of stories, and it was he had them absolutely rolling in the aisles. I mean, people thought it was so apt. I wasn't there, so I missed the opportunity to see this, and I really wish I had. Okay, but now Ernesto knows the reason that I tell stories at the beginning, which is I'm a little nervous, and you do too. And now with the stories out of the way, I've got my footing, and we can go on and talk about this paper. This is joint research, as Ernesto said, with Yang Liu from HKUST, who's an old friend of Ernesto's and mine, and it concerns the topic of inflation, commitment, and reputation. Uh, and what I want to say is during this talk, I'm happy for people to interject with questions, particularly clarifying questions. I will try to pause occasionally, but I also want to make sure that we have time to get through the material and discuss it at the end. And what you'll see in the way that the paper and the talk is laid out is there's lots of pictures. And so I want to make sure that we don't miss these fun pictures. Okay, so I think that there's a general consensus that managing expectations in some form is central to inflation policy. And when we think about this, we frequently imagine a central bank communicating its intentions about inflation, about output, and the policy rate. And increasingly, we can see that in the way that central banks report the outcomes of their policy meetings. Now, when we think about this in terms of macro theory, we portray the central bank as a dominant player in the economy with some strategic power. And ultimately, in theory and in practice too, strategic power derives from commitment capability. You can't really have commitment capability. You can't really have strategic power if you don't have some form of commitment capability. And so when Ernesto Yang and I started thinking about these matters some time ago, we asked ourselves the question, what if the private sector is skeptical about a central bank or more generally a government's commitment capability? And how does this affect the nature of policy choice? And what we realized right away as we started on this activity was that we needed to be very concrete and specific about the nature of private sector skepticism. What other policies does the private sector think can occur? How can the committed policy affect such perceived alternatives? What's the private sector likelihood of the alternatives happening? How can the private policymaker affect the likelihood? And so, as you can see, there are a million questions that come up as soon as you get into this territory. And if experience from a couple of recent presentations is any guide, you will have lots of questions along the way. And so I'll divide those into two parts, ones that I'll answer right away and ones that I'll answer at the end. Okay, so I'm going to start with a couple of big picture facts that motivate our investigation. First of all, if you look at inflation in the United States, we and many other people see some monetary regimes, some low and relatively stable inflation in the 1950s and early 1960s, the great inflation between the mid 1960s and 1980s, 80, the 1980s Volcker disinflation, and the subsequent great moderation. So one thing we're going to build in is going to be regimes. Another thing that we're going to build in is private sector learning. And in general, I haven't worked with models with learning until I got involved in this activity. And for good reason. You have to take a stand on this particular learning mechanism that is appropriate. And my understanding from work that we've done and other people have done is that sometimes the fine details of a learning mechanism matter. So you might ask yourself, what is the evidence that you bring to bear to argue that inflation expectations should be modeled using a learning mechanism? And so this picture shows our motivation. If you look in the early period, there are lengthy runs of positive forecast errors for inflation. The forecast errors are the dashed lines, both original and smooth. If one looks at the top of the figure, you'll see GDP inflation. It's quarterly inflation, and you'll see the forecast, private sector forecast of inflation 1 quarter ahead, that is aligned with GDP inflation so as to produce a forecast error. That is the Survey of Professional Forecasters as compiled by the Federal Reserve Bank of Philadelphia. Then later, starting around 1980, the forecast errors have a different sign. And the smooth error is introduced basically so as to help us keep track of what the average pattern of the errors is. But you can see that they're fairly large, and they have a positive mean before 1980 and a negative mean after 1980. Now, this was first pointed out in some work by Dean Proshure using the SPF and in testing the rationality of survey expectations in 2010, and it's been the subject of much recent research, including the notable work by Koybin, Gurchenko, and Kamdar. That's a survey paper in the Journal of Economic Literature. And so another feature we're going to build in, feature 1 is regimes, feature 2 is learning. Now, that combination occurs in other settings, in particular in Markov switching models, where an econometrician may be learning about the regime that's in place. Similarly, we're going to have random regime switches with 2 types of policymakers. First, there's going to be a committed type who will tell you what he's going to do and then do what he says. And by telling you what he's going to do, he's going to be able to manage inflation expectation. Then there's another type that's variously referred to as discretionary, alternative, opportunistic, etc. We're going to use the language that was common in the 1980s and also in game theory to talk about an alternative type that makes decisions on a period by period basis. So our first guy is going to be committed, and our second guy is just going to choose to do whatever. Now, the way policy will work in our setup is that it's going to set intended inflation. It can't control inflation exactly, but the policymaker can choose the mean of the inflation rate, and we're going to use notation A for the committed policymaker's intended inflation, and alpha for the alternative or opportunistic types intended inflation. And actual inflation will involve a shock, so that actual inflation pi will be, for example, under commitment, A of S plus epsilon. Now, S is the state of the economy, and one of the key features of our analysis is that we're going to be able to build an internally consistent state variable that will include the central bank's reputation for commitment capacity as one element, and we will be viewing the central bank, in particular the committed central bank, as taking its actions A with an eye to managing that evolving reputation. The way in which we're going to model learning will be straightforward Bayesian learning about unobservable type. And so reputation, as I said before, the likelihood of a committed type will become a key endogenous state variable, as in some earlier work that we did with Ernesto that's in the JME in 2018. And at occasional points, I'll refer to the difference between that earlier analysis and the present one. Now, otherwise, this is going to be a garden variety new Keynesian model of a form that people have seen in textbooks. It's going to be inflation today depends on an output gap and a shock that we can think of as like an energy price shock, plus expected inflation. Now, the wrinkle here will be that expected inflation has to be formed in a model consistent manner, incorporating learning and prospective regime change. Now, we're going to develop such a model. We'll tell you how we do that. But once we've got the model, it's going to basically describe a mapping between the state vector in the economy and everything else. In particular, it's going to describe a mapping between expectations at various horizons as formed by the private sector and the underlying state variables. So what we are going to do is we're going to extract these latent states from the 1 quarter ahead forecast of the Survey of Professional Forecasters and the 3 quarters ahead Survey of Professional Forecasters. We're going to have 2 states we need to figure out. So we've got 2 expectations variables that can teach us about what those states are. And we're going to match those exactly. And then, as we'll show you later, once we've done that matching, it'll turn out that we also wind up matching the 2 quarter ahead and 4 quarter ahead SPF forecasts. Now, once we've got those states, then we can tell you everything about how this model works. We can say there's an opportunistic policy alpha, and it depends on the state vector. And we'll take our extracted states and compute our opportunistic policy. And what we'll see is that tracks observed inflation 1970 to 1981 fairly closely. After that point, the model implied committed policy, A of S, again, based on these extracted states, will track observed inflation fairly closely. Now, in all of these analyses that we're summarizing here on this page, we make no use of inflation data. We simply require that we're going to match the state variables that our model suggests are relevant and match the SPF at various horizons. Now, just to place this in the larger sphere of things that economists do, this is an exercise in quantitative theory. It's a quantitative theory that we think shows the potential explanatory power for evolving reputation in a world where individuals can't quite determine whether or not central banks can commit or not, and some central banks can commit and others can't. Now, we don't show that other explanations are impossible. We don't run any horse races, although we're thinking about that activity. And we don't do any econometrics. Our framework is set up for econometrics, but to the extent that we test things in this seminar, we're going to be testing in the sense of Ed Prescott. We're going to develop a calibrated model, and we're going to show you that it has some interesting quantitative implications. Okay, so I promised you pictures, and this is the first one. It's a preview of our results. The black dashed line is the behavior of actual GDP deflator inflation in the United States. Quarterly inflation, not quarterly inflation stated as an annual rate, not year-over-year inflation. So it's a pretty jagged series because there's a bunch of high-frequency action in inflation. Then we have 2 other series that are generated by our model. The one in red is the opportunistic policy actions taken as a function of the state vector, as determined by our model. And you can see that that generally lies above the green line, which is the committed policy actions that would be implied by our state vector. We also see that there is a closer correspondence between the red line before 1980 and the green line after 1980 with actual inflation. And so we're going to, as we'll discuss more below, date a regime change to early 1981. I'll be returning to the lower portion of this panel where we look at the discrepancies, pi minus a and pi minus alpha for this period. Now we're working with 1968. We start in 1968 because that's when the Survey of Professional Forecasters gives us our first data point. And we stop in 2005 for a number of reasons. It allows us comparability with a number of other prominent studies that have looked at the behavior of inflation and policy regimes and so on. I'm thinking here of work by people like Primacheri and Cogley and Sargent and others. It all allows us to avoid having to take a stand on what happens when new policymaker Ben Bernanke comes into play, or the nature of the global financial crisis, and what our model would have to say about this. But we are looking at things over the full sample, and if I have time, I'll come back at the end to discuss what things look like beyond that point. This is a very simple model, and to our minds, this picture says that this simple model has some significant potential explanatory power for the history of US inflation. Now, you will look at the green and red line and say, well, but there was this other variable called reputation. Where's that? How does that come into play? Well, that's part of the state vector, and we'll be describing how that works and the mapping between these two policies and that underlying state. Okay, so this is probably a good time for my first pit stop. Do you have any clarification, or do you, given that I've provided this appetizer, should we just go on?
Hi, Bob. I have a question. I'm Mariana from the bank. Something that I didn't understand and I don't get from the picture is whether your policy is either opportunistic or committed, or you can have both, or they're like two different words.
Now, Mariana, that's a great question. So our vision is that at any point in time, there's only one policymaker in place.
Mhm.
So it's got to either be the red line or the green line. But we can compute, because we know the model and we've extracted the states, we can tell you what each type of policymaker would have done in the circumstances. And the states involve something like an energy price shock to which an optimizing policymaker in a new Keynesian model would want to respond. And what we know from the literature is that an opportunistic policymaker would have some stabilization bias, and a committed policymaker would undertake some smoothing. So there's only one of these two types in place at any point in time. And what we're going to do is we're going to look at this picture and we're going to say, we think it's the opportunistic guy before 1980, so that this green is just a shadow. It's not somebody who's actually in place, but it corresponds to things that, for example, administrations during this period and central bankers that during this period said, which is, we are in favor of having an economy with low inflation and undertaking a prompt response, a prompt reversion to low inflation. It didn't turn out that they wound up doing that, and that's the sense in which they're opportunistic. Afterwards, we're going to view there as being a regime change, but the private agents in the economy aren't going to know in any one of these periods who they're facing. Does that help?
Yes, sure. And one final question to follow up. So, do you get does your model get like a probability of having, the opportunistic policy in place or the committed policy, given that it sees the actual policy?
Yes, we're going to show you a series that we've extracted from the expectations data for the probabilities. And we'll have one probability at every data point. We're using a very simple extraction strategy because we want things to be transparent in terms of the work we're doing. We think there are more sophisticated strategies that could be employed, and we're exploring those. But right now, we're really trying to lay all of our cards on the table. Building a model, we're going to calibrate it. We're going to figure out what its implications are for expectations, conditional on the states, including this probability, which we call reputation. And then we're going to use the mapping to the SPF to extract the states, and then we're going to tell you how the model works.
Perfect. Thank you.
Bob, Ernesto here. Very quickly, maybe this is a question for the broader discussion later, but since the data ends in 2005, I wonder whether some of the forces that you're going to show us here can get extrapolated to episodes of with the zero lower bound.
Okay,
So
so
there can be, so we should look at this from a historical perspective, or we could apply some of the lessons that we're going to get here to some more recent episodes.
and it's a great question. We decided that this whole project was sufficiently complicated for us that we were going to focus on this well-known period. And through 2005 is roughly the period where there was a lot of debate in the United States about the nature, desirability of inflation targeting. There was some concern in the early 2000s about the potential for having zero bound problems, but those, of course, didn't materialize until later. So we thought we're just going to focus on this kind of traditional sample period, but we can show you what the policies would look like absent zero lower bound considerations. And so then the question is, to what extent should we be thinking about modifying some aspect of our model to take into account the zero lower bound? We just didn't want to make things more complicated than we needed to on the first pass through. Okay, if there are no further questions, I'm just going to go on.
Hey, yeah, Mario also from the bank. I have another question. Maybe it's more about semantics. Because what I remember about reading this commitment policy, I think there's like a different definition from the one that you're using. Maybe you can clarify it, help me understand it better for me. Because my understanding is that the other definition uses somewhat that the central bank decides today what's going to do for the rest of the period, looking into the future. That's my understanding of what.
Yeah, that'll be what we're doing.
That's what you're doing here?
Our central bank is going to develop a complete contingent plan, if it's committed, for what it will do in every period that it's in office, in every contingency. I'll show you the dynamic program.
Okay, so it's basically because I remember you mentioned that it reacts to the inflation expectations. That's what you mentioned.
No, if so, I misspoke. Our central bank is going to manage expectations. It's going to be choosing its policies with an eye to the influence that they will have on expectations. We, as analysts, are going to recognize that fact and recognize that our model delivers descriptions of how expectations will respond to the state of the economy, which we don't know. So we're going to use that mapping to uncover the state of the economy. I think this will become clear as I show you what the recipe is for computing these policies and talk about the extraction procedure. But the question is right on target.
Okay, so you basically give a recipe of how, and not just a one trend or just one. Yeah, okay, I see.
Yeah, so I will say there's a theoretical contribution to this paper, and I will highlight it, but I'm not going to go into the details. I'm happy to talk more with people about that in some other setting, but I want to make sure that the general idea and the specific lessons are available to the broad audience.
Okay, thank you.
Okay, so I'm going to describe our model. It's two types of policymakers. Policymaker tau 1, type 1, commits. And as Mario was just suggesting, this guy is going to choose a contingent intended inflation plan for t equals 0 to infinity. T equals 0 is the start of a regime. At the start of any given regime, we set our regime clock to 0. And then the policymaker is going to come into office. It's going to say, I'm a type 1. Here's what I'll do in every future circumstance. There's an alternative policymaker, opportunistic, type 2, and that guy is going to choose intended inflation on a period by period basis. As I said before, we're going to call the committed types policy A, and that alternative opportunistic types policy alpha. And we'll see the decision problems for each that allow us to compute these policies. Now, I've used the language of intended policy, and what I want to capture here is the idea, which doesn't require much rationalization in any central bank context, is that central banks can't exactly control inflation. They can only control it up to some errors, what we're going to call implementation errors. This language of intended policy is one that was actually well established around the time of the early 2000s that we were just discussing, and is apparent in work by Athanasios Orphanides and John Williams at that time. Our central bank is going to have so realized inflation is intended inflation plus a shock. We're going to assume that the shocks that occur have the same volatility across the two types of central banks, although our technology, our methodology is capable of handling a richer setup. Our central bank is going to have a quadratic objective in inflation and the output gap. The output gap is going to be called X. There are going to be variables pi star and X star, which are targets for the central bank. And of course, the central bank is not going to be able to accomplish both of these given the constraint imposed by the Phillips curve. In terms of the behavior of our opportunistic policymaker, the fact that the target for the output gap X star is positive is going to mean that there's a positive inflation bias. And the fact that a target is positive is also going to mean that our committed type is going to be interested in certain kinds of smoothing that will be important for how he chooses to respond to shocks. Now, our committed type is going to be patient, discounting future values of this objective at rate beta 1. Our opportunistic type, type 2, is going to be myopic, but we believe our methodology is readily extendable, not without some computational cost, to considering a situation in which our opportunistic type chooses on a period by period basis, but is not myopic. And again, the myopic case was chosen to allow us to get our head straight about how such an environment might work. Now, I mentioned these two. I mentioned the idea that the central bank can't control inflation exactly as in equation 1, and then I wrote down a central bank objective that depends on inflation and output gaps as realized. Of course, what our central bank will be doing is we'll be averaging over the two over the distribution of these epsilons to choose its intended policy. Now, I should also say that it's traditional in many discussions to assume that the central bank doesn't choose inflation, but instead chooses the output gap with implications for inflation. And in our model, there's an exact equivalence. Once the central bank chooses an intended inflation, it also is choosing an intended output cap. And by contrast, if our central bank chose an intended output cap, that would imply an intended inflation. It's simply easier for us because the model highlights the role of expected future inflation for us to describe things algebraically in terms of an intended inflation policy one. Okay, so in this kind of model, information structure is important. The policymaker type and the policymaker's intention are not observable, but the committed type is capable of making an announcement, which is a truthful announcement about what it will do. The whole nexus between announcements and intentions is something that Ernesto Yang and I studied in our first paper on this topic called Managing Expectations in the JMCB in 2008. And there's some delicate signaling elements that need to be resolved. But when we resolve them, the instructions were solve the programming problem. So that's what we're going to do here in this talk. Our private sector must learn the policymaker type from observing inflation or equivalently observing the output gap in the other scenario that I described. The policymaker is going to be replaced with probability Q each period, and the replacement event is observable. We've opted in this particular study for having the replacement events being occasional rather than according to some deterministic calendar, with an eye to two things. First of all, in the US, it does happen that central bankers, although not recently, that central bankers retire before the ends of their term, notably in the 70s. And it's also notationally simplest for us to have a setup in which the probability of replacement is simply a given number. It's like the difference between having a Calvo model and a Taylor model in the pricing literature. So we're going to have a standard New Keynesian Phillips curve that links inflation pi to expected future inflation on the part of the private sector. And when we need to distinguish between expectations, we'll use a superscript P to denote the expectation of the private sector. There's going to be a slope coefficient kappa that turns the output gap in terms of an influence on inflation. And crucially, there will be a shock on the end of this expression that will be a serially correlated shock, frequently referred to as a cost push shock in the literature, and certainly interpretable as involving energy price variations and others during US history. So this is going to be the nature of the shifting Phillips curve that the central bank faces. It's going to depend on discounted expected inflation, which we'll use the notation little e to describe. It'll depend on the output gap, and it'll depend on this Markov chain cost push shock. Within the period, there's going to be a particular timing of events, and that timing of events will be at the start of the period. The policymaker is either replaced or not. Then the cost push shock is realized, and we think of that as related to the fact that there's a lot of prompt information about energy variations and other things that could contribute to such a cost push shock. Then the private sector forms expectations. The policymaker, knowing the shock and being able to reason about what the expectations will be, takes a policy action that's hidden, either A or alpha. Then there's a random inflation realization, and the random realization and output gap are determined more or less simultaneously, and then we move on to the next period. Okay, so let me just highlight the model elements that we've put in. We've got a regime switching model with private sector learning, but crucially, and in contrast to most settings where one studies regime switching, we're going to have a purposeful policymaker that's going to be using its policy to manage expectations, and in the process, managing its reputation. We're going to have a purposeful, opportunistic policymaker type that responds to expectations. And this will distinguish the work that we're doing here from the earlier work that we did with Ernesto in the JME in 2018, where we had a mechanical alternative policymaker. And that's differences of substantial importance, both for potentially interpreting the 1970s in the United States and for the operation of our model. And I'll come back to that distinction later on at various points. We're going to have what is called in the game theory literature imperfect public monitoring. We're going to have rich reputation dynamics, and you can think about policymaker who brings about high inflation as facing a certain kind of punishment in terms of declining reputation, deteriorating reputation, that will be important. And as I said before, there's going to be forward-looking expectations, and variations in expectations can be used to smooth shocks under commitment. So we're going to have a dynamic game that Ernesto and Yang have taught me a lot about over the years. Within the game, we're going to be specifying things kind of pedantically in terms of history. And to be honest, the reason we're specifying things this way is that a key part of the theoretical contribution of the paper is to understand how to write down an optimal policy problem in a world where private agents have different beliefs from the policymaker. And so we wanted to be very specific about who knows what. Little h will correspond to the public history that is going to be the behavior of inflation and these cost push shocks. And a policymaker taking an action is also going to know his type. So he'll be basing his actions on that information plus the public history. But the public history is all that the private agents will have. Now, I should say that this is history within a regime. And as I said before, if a new regime starts, the regime clock is set to 0. We think that a new policymaker is endowed with a reputation, row 0, that is a random draw on the interval between 0 and 1. And the new public history for that decision maker will be row 0 and the cost push shock at 0. The model technology allows us to include some reputation inheritance in which a policymaker of a new type inherits some portion of the reputation of his predecessor, say Greenspan and Volcker. Okay, so inflation expectations are the main element in this model. And so I want to talk about two different kinds of inflation expectations that are relevant in our framework. First of all, in a given period, the private sector can form a nowcast of inflation. And that nowcast of inflation will be whatever the probability row 0 that it attaches to the likelihood of a committed type times what it knows the committed type will do in this history. It knows the public history, one part of the public history is row 0, so it can say the nowcast of inflation is partly based on that action. And then with probability 1 minus rho, the policy is going to be based on the alternative type alpha 0. And at the start of a new regime, that nowcast has got to be conditioned on the random draw of of what the reputation variable will be. Now CAS can always be computed in subsequent periods, but does not play a behavioral role in our model. Our private sector expectations that are relevant is those about next period inflation. And once again, they involve a weighted average, a probability weighted average, with the weights being the likelihood of policymaker type rho and 1 minus rho of the inflation that will occur next period if there's presently a committed policymaker in type, and if there's presently an opportunistic policymaker in type. And as one can see from above, what will happen if there is a new regime will depend potentially on the kind of next period will depend potentially on the reputation that's in place in this period. So we allow for that in our modeling enterprise. Now, the opportunistic type is going to be very simple. It's going to be very much like what's sometimes called a discretionary policymaker. So if you're familiar with the Galli and Gertler and Clarida treatment of the policymaking without commitment in the new Keynesian model, this is our framework's version of it. It's textbook material in the book and the works by Galli, Woodford, Walsh, and many others. And what that means is that there is a linear best response that our policymaker without commitment has to the expected inflation rate. That expected inflation rate is start of period information. It's conditioned on the history, including the current cost push shock squiggle. And so there's a linear best response to expectations, and then there's a shift term that involves how a policymaker without commitment will respond to that element of the state of the economy. Now, this policymaker doesn't directly have any concerns about reputation or reputation management, but he is influenced by the reputation that's in place as it influences expectations. And this policymaker would like expectations to be lower. And so he's going to be better off if expectations are lower. But if expectations are higher, this policymaker will find it optimal to partially accommodate that rise in expected inflation. And that's the extent of that accommodation is given by the parameter A, which depends on the structural elements of the model. This optimal policy by the alternative or opportunistic type responding to expectations is a key way in which this framework differs from our earlier work with Ernesto. And the endogenous response is central theoretically for us and also to the quantitative account that we give of U.S. inflation. Okay, so now what about the nature of the committed types decision problem that Mario asked about? At the start of his term, which is dated 0, our committed type is going to look forward and choose an optimal contingent policy for every period that that he will potentially be in place. And so he's going to discount at rate beta 1 and 1 minus q because there's some chance he might get replaced. And he's going to be maximizing that objective that I talked about before. But I've simplified this objective in 2 important ways. First of all, I've taken the Phillips curve and I put it in so the expectations enter directly into the policymaker's objective. That's for notational and presentational simplicity. I've also assumed that the central banker knows, well, inflation is going to be distributed around my action A, and I've already integrated out the uncertainty that he has with respect to the exact inflation. So we get a reduced form objective, U under bar, that depends on the policymaker's action, the expectation, and the cost push shock. And critical element for this policymaker with commitment is going to be strategic power that his commitment capability gives him over expectations. He's going to announce the sequence of things that he's going to do, and private sector is going to look at that and they're going to say, well, I'm not quite sure who's around, but if it's a committed type, he's going to do that. And then that will have an influence on how they form their expectations. It lets the committed policymaker manage, but imperfectly manage expectations. It lets the policymaker committed policymaker, potentially manage the alternative policymaker. Because the committed maker knows that by influencing expectations, he can also affect the optimal choice of the alternative. And then the two of those wrapped together are going to be important for the rational expectations determination of expected inflation. The third thing is that our policymaker, as he's thinking about the world, thinks about how different his policies are going to be from those of the alternative type. And he thinks about the implications that that difference will have for the evolution of reputation over time via the Bayesian learning mechanism that I described earlier. Okay, so once again, this might be a good time for a pit stop. Any comments, questions, observations? I'm just checking the time because I want to make sure I get to these pictures.
I have a something that if you want to postpone, it's okay. As you've been presenting the setup, I am wondering whether having persistent implementation errors may make a difference in the way that the problem is cast or may bring some new insights on it.
Okay, so we don't know the answer. We'll come back to talk about what what our hypothesized implementation error looks like. And it looks pretty white noisy to me. So we did white noise because we could handle it. And then it turns out that it kind of looks like it's white noise. So we're happy. Mario, did you have a question? Oh, okay. All right, I'm going to go on if there are no further questions. Okay, so now what I'm going to do is I'm going to deliver a recursive formulation of the optimization problem for this committed decision maker. It's going to take into account rational expectations on the part of the private sector, the evolution of reputation, and in the way that we structure it, it's going to take into account an incentive compatibility constraint for the behavior of the alternative policymaker. So our vision is going to be that the committed policymaker will choose everything. He'll choose his actions. He'll choose inflation expectations subject to a rational expectations constraint. He'll choose the behavior of the alternative policymaker subject to an incentive compatibility constraint. In this way, we're really proceeding along what I think is a conventional practice in macroeconomic policy design, where we view the committed central bank as having strategic power relative to an atomistic private sector. We're now applying that same set of ideas in a mechanism design setting to thinking about an alternative policymaker, with the recognition that there are never going to be both of these policymakers in place at the same time. So that management of the alternative policymaker's behavior from the standpoint of the committed type is going to be based on his interest in controlling expectations. But then it will also turn out for us, and this is a novel element in the analysis, that once we've laid out the equilibrium that we'll describe, we can also talk to you about what an optimizing alternative policymaker would do absent commitment. So the mechanism design approach that we're adopting turns out to be powerful in terms of letting us solve the model, and it also turns out to be desirable in terms of letting us make quantitative statements about the evolution under an alternative policy regime in which there is not commitment. Okay, so I just told you this, but now here's some equations. We're going to have a mechanism designed for computing a within regime equilibrium. The committed policymaker is going to maximize a present discounted value objective. It's going to be subject to 3 constraints each period: rational expectations, in that the little e that the policymaker chooses is going to be the private sector's conditional expectation, given the public history that it has. There's going to have to be incentive compatibility of opportunistic policy, which here we write as this linear best response. And there's going to be Bayesian learning, in which the actions of both types of policymakers figure, because the private sector, in interpreting the data that it sees on inflation, is thinking, is it more likely that it came from this committed guy or this alternative guy? Now, there you can see a little button down there that says change of measure. And I'm not going to go through that, but I will simply say that this is a policy design problem with 2 different sets of beliefs: the beliefs of the private sector and the beliefs of the public sector. And so in order for us to convert this into a conventional recursive optimal policy problem, we had to undertake a change of measure. And then once we figured out how to do that, things worked pretty well. And the idea of a change of measure, we believe, is also something that is going to allow us to crack a class of problems with long horizon alternative decision makers. Okay, so what does the recursive optimal policy problem for the committed type look like? Well, it's going to pay attention to reputation building. It's going to involve this committed type using its commitment capacity to manage expectations. And so we're going to have a generalization of a Bellman equation where the committed type says, I'm going to take as given the state of the economy as described by reputation, that's one state, and the other public history state, the cost push shock. But I'm also going to remember that I've said things in the past that I have to follow through on. So in the approach that began with Kidlin and Prescott in a Journal of Economic Dynamics and Control paper in 1980, was further developed by authors like Marcet and Merriman and others, that I've used in a number of settings with policy, optimal monetary policy, with complicated price dynamics. We're going to be making use of this lagged multiplier methodology, if you like, a pseudo state variable in the language of Kidlin and Prescott in 1980, to keep track of the promises that the policymaker will make. And so the policymaker at a given point in time is going to choose A, his action, the expectations of the private sector. He's going to be doing so understanding that there's a price, gamma, attached to adjusting expectations that is associated with, it's a Lagrange multiplier associated with the forward-looking expectations constraint. And there's going to be a requirement that he carry through on things that he promised to do in the past. And in this framework, the pseudo state variable that we carry along is going to take an unusual form. In many settings, it will involve a lagged multiplier on the forward-looking expectations constraint. And indeed, in equation 12, it involves that. But it's also the case that in our compact description of this problem, it turns out to be desirable to use both a combination of the commitment multiplier and the reputation variable to reduce the dimension of this system down to 3 state variables. The 2 intrinsic state variables and the 3rd pseudo-state commitment multiplier. And the details of this, you don't want to look at that, but they have to do with us carefully working out how should this policymaker carry along its past expressions of what it's going to do and the implications that that has for expected inflation. Of course, I'm happy to talk more about that, but it's not the main target of this seminar. Now we have a recipe. We have a machine, a dynamic programming-like machine that I promised Mario, to compute what the optimal policy looks like within a regime. We've got these 3 state variables, and we're going to be looking at cross regimes and understanding that a new regime might take place, in which place there would be a commitment multiplier mu of 0. And so that there would, that is, a new regime would not involve honoring the commitments of the past. So there's going to be an expected inflation variable. And so we use a within regime mechanism design approach and a cross regime, a Markov perfect equilibrium approach with a fixed point to do this in a coherent way that captures the critical elements of both regimes, commitment within a regime and the recognition of what a successor will do across regimes. Now, right here, we've got 3 state variables. And we're pretty damn proud that we have 3 state variables. We've taken this complicated intertemporal model and we've boiled it down to 3 state variables so that we can actually solve it and talk to you about what the lessons are. And further, that's also going to be the core element of making this model quantitative. Now, it turns out that we can simplify that problem that I had on the previous page a little bit more. And when we do that, we highlight 2 variables that a committed type is choosing that can both be employed to think about managing expectations via what we call an operational expectations function that simply says, take the expectations of what the future decision rules will be. And those are 2 variables. One is what we call delta. It's the difference between what the 2 policymakers will do. And that drives reputation and learning. The second is the commitment multiplier that will be carried over to next period. And that manages the expectations of the private sector. So when we actually go to calculate this problem, it's desirable for us to have a reduced dimension problem that boils down the 4 things that we had to compute in this problem to 2 things that we can compute. And there's a proposition in the paper that lays out this in detail. But it's also super intuitive. What's our policymaker doing? Respecting rational expectations, choosing how different to be from the other type in order to motivate reputation building, and choosing what to promise in terms of next period inflation. The nature of that reduced decision problem is given on this page, and in the interest of time, I'm going to skip over it, but that crucial feature is that it allows us to significantly simplify the computation, and it also provides us with a rubric for thinking through what a policymaker is doing at any point in time. He's choosing delta, he's choosing mu prime, subject to an expectations constraint. Now, I should say, I briefly touched on computation. We have adopted a very cautious computational strategy in this, basically because we didn't know what to expect in a world of learning. There are cases in which learning can lead to objectives that involve non-concavities, etc. So we've really very literally chosen to adopt a pure maximization approach, and pure constraint maximization approach, looking over a very big grid, and in the process, we've had to learn how to use the cluster computing system at BU. Now, in view of the fact that we've determined that the policy rules are kind of smooth, that suggests that we might be able to dramatically accelerate computation, which would be important for doing econometrics. Okay, so now, once again, I'm going to stop for a second, see if there's any critical questions that need to be raised. Okay, I'm going to go on. All right. So now what we're going to do is we're going to build a quantitative model. And so the first part of this quantitative model is going to be thinking about the behavior of an opportunistic policymaker and in a world without commitment. And this is something that we can really do to a significant extent without having our whole model. So I'm going to take you through this in 2 steps. I'm going to describe how you might kind of produce a back of the envelope calculation. And then what we'll do is we'll see how this works out in the quantitative enterprise. Now, what I mean by the back of the envelope calculation is we've got this best response function, alpha, that depends on expectations and on cost push shock. And in thinking through the economics in this area, we found it useful to distinguish between 2 notions of inflation bias that seem relevant for a decision maker that can't commit and the equilibrium that he will produce. Now, very frequently, the way we represent a Nash equilibrium is by a picture like this square graph that I've got, where we've got, on the one hand, the expectations variable, E, that is sort of the behavior to which the decision maker is responding. But this decision maker ultimately is generating inflation. And so the Nash equilibrium in this economy is the intersection of the best response function in red, alpha, that's linear, and the 45-degree line. That's a situation in which alpha is equal to expected future inflation, or E is equal to beta times expected future inflation. So we're going to structure this problem so that we have 8% Nash equilibrium inflation bias. The parameters that we will select have that attribute. And that's because we're trying to match something like the height of the US grade inflation. It also turns out that when we do that, we are led to parameters in a standard quadratic objective function that place greater weight on gaps between output and target output than in the conventional micro-based new Keynesian model. So I'm going to be right up front. We're going to have more weight on output gaps. That's another thing that's going to differentiate the work we're doing here from the work that we did with Ernesto before. But that greater weight is not different from what studies of the US central bank's policy models during the 90s and the 2000s would suggest in terms of a relative weight on inflation and unemployment. You can use output gaps and Okun's law to back out these relationships. And the weight we're placing is not in any sense crazy relative to what policy models, how policy models were constructed. If anything, I think we're putting a little bit less weight on output gaps than the policy models themselves did. And we're going to maintain that same set of weights when we study the commitment problem later on. So we're not going to have any changes in weights that the policymakers place on gaps, but we are going to be using a little bit different set of, well, maybe a lot different set of parameter values than you may have seen in other studies. So that's what Nash equilibrium inflation bias is going to look like. But many central bankers say something like, oh, I've worked in a central bank for a long time and I never saw any inflation bias. I never saw anybody say we should increase economic activity excessively, blah, blah, blah. And Alan Binder has been very explicit in his lectures on his time at the US Fed and saying he just didn't see much in the way of a tendency for inflation bias. But in those same lectures, Binder talks about the importance that's attached to a central bank having a dual mandate and being concerned about output gaps as well as inflation. So what we are going to do is we're going to have in our model something we call intrinsic inflation bias. It's how much a policymaker would raise inflation relative to expected inflation. That's going to be iota, this variable here, and it's going to be the intercept of our best response function. So we're going to have a model with a little bit of intrinsic inflation bias and a lot of Nash equilibrium inflation bias. And we think that that is plausible on a range of different grounds, including the narrative that I just gave you. Now, in order to turn a small amount of intrinsic bias into a large amount of Nash equilibrium bias, you've got to have a line with a best response function with a slope that's pretty close to 1. And so our parameter capital A is going to be big. It's going to be 0.94 in this calculation. And frankly, 0.94 is worked out from having 0.5% of intrinsic bias, a small number, having 8% equilibrium bias, a big number, and then, division basically tells you what you got to have. And so we choose A equals 0.94, but A in turn is based on these relative weights and inflation and output in the central bank objective. It's also based on the slope of the Phillips curve. And so a fairly flat Phillips curve, traditional from the standpoint of the early 1960s, but also compatible with much recent research in macro. Pretty flat Phillips curve, a pretty big weight on the output gap is going to lead us to have this value of A. So we don't think it's outrageous. Now, once we've got that, and we have the survey of professional forecasters, even without any cost push shocks, I can create a back of the envelope measure of what an alternative policymaker would do. And so that's what I've done in this graph down at the bottom. I've got a red line, that's the alternative. I got a blue line, that's expectations. Yeah.
Very quickly, it would be great if you could wrap up in a little bit of less than 10 minutes or so.
Yeah, I'm rolling. Okay. But this is crucial. This is one of the big ingredients that lets us get the history. Okay, so I am going to skip calibration. How do we turn our model into an operational one? Well, I said before that the theory says there's 3 state variables. That means that everything in our model is going to depend on these state variables, including the actions of the 2 policymakers and the forecasts that people would make in the model. So the model forecasts are going to be functions of the state variables. We have data from the survey of professional forecasters. So what we say is we have two state variables we need to know. One is the cost push shock. The other is the reputation variable. We're going to require that at each point in time, we match two parts of the SPF. Now, our intuition about looking at the SPF, and in particular looking at forecasts at 1-3 periods horizon, is based on analogies to the term structure literature. The thing I want to fix in your mind is that during the explosion of inflation in the 1970s, there were things that people at the time and researchers subsequently viewed as cost push shocks. Those were viewed by the participants in the SPF as transitory. And so the near-term SPF moved up more than the longer-term SPF. And so it's that feature of the data that lets us extract both a reputation variable and a cost push variable that has an autoregressive set of characteristics. Now, I should say that theoretically, our reputation variable has to be a martingale from the standpoint of the private sector. So if you think it's going to be a random walkie variable, that's the right background. So we fit two parts of the SPF, and then we can create what the rest of the SPF looks like. No prizes for getting the thing on the left or right, because that's what we were targeting. But we give ourselves a little bit of credit for being able to hit things on the right. And if I have time at the end, I'll come back to talking about what our model says about longer term expectations measures, which were not computed in the SPF until later. Okay, so now we're back to my preview. The preview was, I got a model, I got some state variables. The state variables are going to imply the behavior of these two policies. And now what we're going to do is say, when did a regime change take place in the United States? Now what we can construct is the difference between observed inflation and inflation under either type of policymaker. When we do this, 1968 over 1970, and we assume that an alternative policymaker is in place, we have an average of 0. And in terms of your earlier question, Ernesto, it looks pretty serially uncorrelated to me. If we look at a later period and we can assume there's a committed policymaker, once again, the errors average pretty close to 0. They're positive if we make the alternative assumption early on, and negative if we make the alternative assumption later. So we declare there's a regime change in Q1 of 1981. Now, that is based in part on a careful historical investigation that Marvin Goodfriend and I did of the FOMC transcripts around during the Volcker disinflation period, where we date the start of the Volcker disinflation to the Reagan support for the central bank that took place when Reagan came into office. But Yang, in a prior life, was someone who worked on dating regime switches, and she will tell you it's tricky business. You know, if you told us it was here, if you told us it was here, it would be hard if we had the full likelihood written down to know exactly where. But we're going to go with 1981 Q1 as our regime switch. And so, in terms of the earlier question that was asked, we're going to declare that the early period policy is the red line, later period policy is the green line. Okay, so now we've gotten our conclusion or our preview. Now, people ask, can you tell us what the reputation variable looks like? And so the bright blue line here is our extracted series of reputation. It's fairly high in the early years because expectations are low. It falls during the rapid acceleration of inflation in 1973-4, where there were energy price shocks and the end of price controls. But inflation expectations stabilize after, that's the dark blue line, stabilize after that period. And then, so does reputation. Because reputation and the level of expectations, in some sense, are hooked together according to our methodology. But then as inflation continues to move up later, our extracted reputation deteriorates. And once again, that's because expectations are moving up in a permanent way, and not just in a transitory way. We have two measures of the extracted price shocks down at the bottom. One is the literal extraction, and the second is that SPF spread that I referred to earlier as a motivation for us. So there you go. That's our history in terms of the evolution of reputation. It's our history in terms of the nature of policy, with during this period, people thinking that there is a committed policymaker, a opportunistic policymaker in place, but knowing that maybe there could be a committed type. And the fact that they know that there could be a committed type, given reputation, holds down expectations. And expectations hold down the action that an opportunistic type would take. So we do have during this period a kind of a time series version of that square plot that I showed you before. And you can see during the later periods that we have a reasonably close correspondence between the green line and the black dotted line, which is the behavior of actual inflation. Now, in order to understand what's going on, we do a number of things. We conduct a historical decomposition. We hold fixed the reputation variable in the policy functions, and we use the policy functions at the sample mean of 0.6 to see what would have happened if there had been no reputation variation. And we can do that from the standpoint of the committed type policy, the alternative type policy, and the difference between the two, the variable delta, which is related to reputation. And so one thing that I would point your attention to, I'm not going to be able to go through this slide in detail. There's some good discussion of it in the paper, but during this interval here, the gap between the committed and alternative policy is sharply negative. It's A minus alpha. That's associated with, in our view, a committed central bank working to generate offset a decline in reputation. We also have some lessons that we can go through in terms of the effects of reputation on decision rules. In the interest of time, I'm going to skip over this detail, but we'll distribute a copy of the paper, and it's well explained in the paper. I want to go through and I want to talk about some policy simulations. And what we have here is a new policymaker coming in at date 0. People don't know which type it is. They don't know if it's opportunistic. They don't know if it's committed. Early on, according to our model, there is little difference because intended inflation bias is small in terms of what the two policymakers would do. Therefore, it's hard for people to figure out what's going on. And reputation is fairly constant for an extended period. This particular policy simulation is based on the idea of thinking about the 1970s when there was a supply shock. And The supply shock is something that the alternative policymaker that isn't committed will respond to more elastically. That's associated with the idea of stabilization bias that's much discussed in the new Keynesian model. But in our setting, when that policymaker reacts strongly and accommodates the inflation shock, that's important for private sector learning. People learn and reputation declines dramatically because they learn. In addition, the more reputation declines, the more there's a gap between what the two policymakers would choose to do. And so that reinforces the effects of this shock. And asymptotically, over here on the right, the private sector learns. So what we see here is slow learning for a long while. It's a supply shock that speeds up learning, produces a decline in reputation. The internal reputation dynamics of the model produce discrepancies between the two types of policymakers' actions, in turn reinforcing learning and ultimately leading to a Nash equilibrium, high inflation. Now, I want to close the presentation with 3 fun slides. And fun slide number 1 is, what would have happened in the United States if we had always had a regime of commitment? And in particular, how would the 1970s have been different? So to be clear, what do we do here? We take the same shocks that our model has extracted, but we assume that reputation is always one. People know there's a committed policymaker. The policymaker knows that people know. And so it's really the standard new Keynesian policy exercise that you see in textbooks. But with our shocks, our extracted cost push shocks. So as we discussed before, in the 1970s, there's a cost push shock, according to our model. Our committed central bank with imperfect credibility, well, he can't really manage expectations very well. So he's going to wind up partially accommodating this. He won't produce as much inflation as an alternative opportunistic policymaker, but our committed policymaker with an understanding does exactly what the new Keynesian model would say: smooth the shock. Let inflation increase for a little while, but promise people you're going to bring the economy back to a smooth price level path by having more inflation now and less inflation later, around a target of 2%. And so the behavior of this model is dramatically different during this period. And for me, at least, it's hard not to look at this picture, having been there in the 70s and thinking about now, thinking about the difference between policy with commitment and policy without, and hoping that the U.S. is closer to commitment than to the policy of the 1970s. Now, we also do the counterfactual for explaining why reputation is essential. And this is actually something we could have guessed what I just showed you, but we did not really appreciate going into this project how differently an economy where people are learning about a policymaker without commitment is from an economy where people know there's a policymaker without commitment. Policymaker without commitment that's known is the standard textbook construction. Lots of reinforcement between expectations and outcomes. And that's the solid red line here. But our policymaker in a world where agents are learning, well, he knows that expectations are not too high. He doesn't need to respond strongly. So the time series implications are really rather different. And some people have rejected models of incomplete commitment as an explanation of the 70s by saying, well, if there wasn't commitment, why wasn't there always high inflation in the 70s? If there's learning, there's an answer. It's because it took people a while to figure it out. So we like this counterfactual too. And then we've got a final element. Central bankers and economists talk a lot about credibility. They don't talk so much about reputation in models, and they don't try to measure reputation so much. There's a strong association, however, between our two commonly discussed measures of credibility, something called a credibility gap, the difference between the committed policymakers' announcement and the private sector's nowcast of inflation, and the degree of credibility, which is the likelihood that inflation will fall within a band around the committed policymakers' announcement. Each of those are used in various ways in theoretical and empirical literature to talk about imperfect credibility. And what you can see is there's a very strong association in our model between our extracted reputation variable, the reputation for commitment, and these two credibility measures. And that's the reason that that's true is because reputation is a state variable. And arguing that reputation is a core state variable that economists should be seeking to measure in ways that complement discussions of the importance of maintaining or accumulating a reputation in central banking is a sort of core theme of our research. And so I think there's no better place to end than with this picture. We've got reputation, we've got credibility, and behind all of it, we have a model and an approach for studying these issues